Good day, class. So, as we've discussed last meeting, in regards to belt, so belts are a flexible band uh, that connects pulleys or to convey materials by transmitting motion. So, belt is under FPTE or the flexible power transmitting element. So, the use of belts are, of course, we need to have the power transmission. We have a convey service and we have the elevator service. So we have two types of belt connections, or we have two belt arrangements. So we have open belt and a cross belt. So if it's not indicated in the problem, if it's an open belt or a cross belt, we will always consider an open belt. Okay, so we have different types of transmission belts also. Uh so you have this flat belts, you have the V belts, you have the tooth belts. So of course, flat belts are ideal for long distances and high load capacity operation. So for V belts, for high torque transmission and good for grip and durability. And for the tooth belt, we have the high speed applications. So we have different types of belt material as well. We have the leather, we have rubber, we have stitch canvas, and also the advantages of each belt. So, or for the flat belt, it is cheaper, and it can be used in dusty and abrasive environment. So it also has high efficiency, no? But the disadvantage is, of course, it is noisy, and also the tension should be high. So or in order to keep the 2% of the slow 2%, no? And also the tension result uh, in high bearing loads and belt stress. Okay, so that is for the flat belts. Okay, so also we are for the parameters in considering belt design. Of course, we have the strength of the belt, no? So um we also have the arc of contact, we have the center distance, we need to have also the centrifugal force, the friction, and the thickness and the width and the working stress. So for the belt tension, we need to have an adequate tension, which is crucial for the efficiency of the transmission of the belt from the driven shaft. No? From the motor shaft to the driven shaft. So we need to have a minimum or at least negligible slippage for you to have an optimal result of the conversion of the power. And also we had to have a pulley alignment. So for you to have a smooth operation. And of course, we need to reduce the wear and tear of the belt. So uh so in the previous meeting, we need to have the failure of the belt will be with respect to the slippage, the cracking, and the tearing. No, so for you to have a good economic life of your belt, you need to have a good maintenance and inspection. So you need to have a visual inspection, alignment check, the tension check, also, and also of course the housekeeping or the cleaning of the belt itself. So for you to have a better uh, selection of your belt, you need to know what is the load to be used, or what are the capacity uh, of the materials to be used. No? So you need also to know the speed to in consideration for this the operating speed, no? And also the environment. Is it humid? Is it high temp? Or full of chemicals and oils, no? And um, also for the belts, no, for the V belts, we have the heavy duty industrial V belts, no? So we have also industrial narrow section V belts. We also have the standard, of course, the standard belt cross section or the standard V belt. So we have the classification of the V belts. We have VV drive, so meaning both driving and driven pulleys are in sheaves. So we also have V flat drive, which means the driving pulley is a shave, while the driven pulley is a plain surface. So we have different standard sizes for V-belts. We have A, B, C, D, and E. No? So it depends on the thickness and the width. Okay. So the advantage of a V-belt is that it cannot come out of the grooves. No? We also have the wedging action that permits a smaller arc of contact. And also, shorter center distance can be used. No? And gripping action results in lesser tension. Okay, so these are quieter than the flat belts, no, when in high speed, no? And also the drive is capable of absorbing the high shock, no, and it has better initial installation and replacement. Uh, Also, the procedure in calculating the V belt, you need to know of course, the size of the belt. You need to know the standard size of the sheaves, the length of the belt, and also its specification, and how many belts should be used. Also, these are all for machine design. Okay. So next we have our problem solving. Okay. So for the first problem, how long a piece must be cut off the belt if the two shafts, 4 meters between the center carry pulleys 1.5 meters in diameter and 1 meter in diameter respectively. So connected by a cross belt, but it is desired to put on a belt as an open belt. Okay, so we need to know first the length in an open belt, and also we need to know the length in the cross belt, and then we will have the difference in the length. Okay, so we do for the length of an open belt. So the formula for that is that L1 is equals to pi over 2 quantity D1 plus D2 plus 2C plus D2 minus D1 raised to 2 all over 4C. So we have D1, we have 1.5, and D2 is 1. Then we have the center distance of 4. Okay, so we just substitute it. So we have pi over 2 multiplied by 1.5 minus plus 1,000 plus 2 times 4,000 plus 1.5 minus 1,000 squared over 4 times 4,000. So length 1 for the open belt. Okay, so we calculate that. So we have okay, so I over 10 over I over 2. Okay, I compute it. So that will be 160. We have 2 multiplied by 1 by 2 5 plus 3,000 plus 1 plus over 4. So we will have 11,942.625 mm. So this is for the open belt. So for the cross belt, we have L2. So that will be pi over 2 quantity D1 plus D2 plus 2C plus D2 plus D1 squared all over 4C. So we just substitute. So we have pi over 2 D1 plus D2. So we have 1 pi. So we just copied this, and then the difference is that this is for open belt, we have a minus and then plus for the cross belt. Okay. So just copy this 1 pi plus 1,000 plus 2 4,000 plus 1 5 plus 1,000 squared all over 4 times 4. Okay, so you just compute it. So you will have the length of 1,200, 12,000, sorry, 12,317.625. So you just deduct it, 11,942. Okay, 1,317.625 minus 11,942.625. We will have this length or the difference in length between open and cross would be delta length is equals to L2 minus L1 or 25 minus 11,942.625. 11,942.625. So this would be 375. Okay, next. So next, find the belt net tension if a flat belt is 8 inches and 1/2 thick transmits 40 horsepower. The center distance is 10 feet. The driving pulley is 8 inches in diameter and rotates at 2,500 RPM, such that the loose side of the belt is on top. So the driven pulley is 20 inches in diameter. So the belt material is 0.35 pounds per inch cube. Okay. So in order to get the net tension, we have F net equals to F1 minus F2 equals to 2T over D, or it would be 2 over D, 63,000 HP over N. So we have 2 over 8. Then we have 63. This is a conversion, no? All over N, which is 2,500. Then the HP is 40. So we just compare this. Six. Divide by 40. So we have 2 over 8 multiplied by 63,000. Oh, that's not 63,000. Okay, we can get the F net is equivalent to 252 pounds. Okay. Okay, so next, determine the speed of a driver of a 1,000 millimeter driving pulley uh, are arranged on a 3-meter centers. The output driven shaft, which is 90 horsepower. So the belt speed is assumed to be uh 1,200 meters per minute with a coefficient of friction of 0.2, 0.3, sorry, and a slip of 1% each pulley. So determine the speed of the driver. So we have here the driver. So this is counterclockwise. And then the bigger one will be the driven. So we have here, we will have uh 1,225 millimeter. And then from the center distance, uh, would be 3 meters. And then here, the driver The driver will be. Oh, sorry, it's okay already. So we can use V because of pi dn quantity 1 plus the percentage of a sleep if there is. If not, this would be 0. So this is 3 minutes. So you have 1,000 uh 200 meter per minute. So you have here 1,200 equals to pi. The D would be here, the 1,000 plus uh 1 plus percentage of sleep is 1% each pulley, so 1. So 0.01. So the driven 1, 2, 3, 4, 5, 6, 7. Okay, so divided by so 1,000. So you have the end driver. Mhm. So the and driver. Right. So you have 1,000 here. ID. So you have it here. So this is like instance or instance. Okay. So that would be 1,000. 1, 2. And just do this. So 5.1416 times 1,000 is 1.01. So you have one driven equals to 3117.016 RP. So for this one, so you have a belt connects centimeter 15 centimeter diameter of the pulley and 32 centimeter diameter pulley with the center distance of 55 centimeters. So we have this a pulley here, a pulley bigger here. So it's like this. Then this is the center distance. So you have formula of the theta. Theta is equals to 180 degrees minus 2 alpha. Okay. So in order for you to get the alpha, ito medyo no? Sine inverse d2 minus d1 over 2c. Or you have another formula, sine inverse 30 minus 10. Sorry, not 30. 32, 15. 32, 15. With a center distance of 55. Times 55. Okay, let's get the alpha. So sine inverse 1. 32 minus 15 all over 2. The minus 15. Here, sine 52 minus 15. Mhm. So shift sine 32 minus 15. Okay. Sine inverse. So that would be the alpha is 8.8. Okay, so that is your alpha. So you have theta equals to 180 minus 2 times the alpha that you have already got. Would be 8, 8. So that would be your arc of 2, 8, 8.89. Services 162. One 20. Yes. So I'll just give you some practice problem for you to do with the topic. Okay. See you. Thank you.